Everyone, welcome back to the class of Math 1450, Math and the Modern World. And this time, we are moving to section 5.4, Ratios and Proportions. And indeed, I want to say, really, there are a lot of times we want to consider ratios. And for example, in America, we use dollars. And if you travel, let's say if you go to Europe, and probably you need to, certain merchandise or some shops or stores, they do accept American dollars, but most likely you need to use their money, which is euro. But the world is not perfect. It's not exactly the situation. You have $1, you get €1. The actual situation, it is not like that. And so here's the example on the textbook. And the actual number it is from, I think it's 2021. Basically says $1, it is worth for it has less value compared to €1, really. $1 was worth 0.82 euros, and we want to write this comparison as a ratio. And to write this ratio in a very simple way, you can say, okay, it is 1 to 0.8, which simply means $1 is 0.82 cents, or simply $1, simply it is for 82 cents of euros, 82 cents of euros. And sometimes instead of using the word two, you can use the semicolon notation. I think we read it the same, right? The ratio is 1 to 0.82. Or it is very common, we simply denote a ratio as a fraction, 1 over 0.82. That is a ratio, that is a ratio, that is a ratio, that is a ratio, okay. And now let's take a look at how the ratio really works, Let's say you are taking a trip going to France, and France, it is a part of the Europe, or it is a major part of the Europe. And you have $520, and you also want to, you clearly want to make it to euros. You want to make it to euros. And you do know $1, it is 0.82, like the example we just did. And you want to see how much money you could get in euros when you convert $520 into euros. Okay. So in this case, first of all, we can separate an equation, because you can say we have two ratios, right? One, it is a standard ratio, $1, it is to 0.82. And then we want to find out how much it would be worth in euros. So it is 520 to x. Well, this time it's worth to explain a little bit better about the notation. We do use x a lot, but for different problems, x may mean different things. So this time we are going to let x to denote the variable that represents the unknown amount of euros. Okay, x is the amount in euros. So because they're going to have the same ratio, that's the constant proportion. In this case, the ratio it is called as constant proportion, and we'll talk about a little more the next example. It is constant proportion. Okay, so for the moment, we are going to set those two ratios the same, because clearly for any amount, $1 it is just for 0.82 euros. So 1 to 0.82 got to be the same as 520 to x. Because this time we are really comparing two fractions. Okay. A over B is C over D. We can consider the cross multiplication. A over B equals C times D. It is the same as A times D equals B times C. This is the cross multiplication I'm talking about. Okay. And then with those specific numbers, we have the following: 1 times x, it is 520 times 0.82. So we just figure out the actual amount for $520 in euros. It is 426.4. 426.4. Does it make sense? And because this is, first of all, I really want to say 426.4, it is a good answer. It is a good answer. But anyway, keep in mind that we use math to solve real-world problems, right? So in the end, for this type of problem, you do not just want to leave a number as an answer, and you want to make your statement. What is your answer to the actual problem? So this is a statement made by the textbook. Okay, that's the actual meaning of 400. The actual meaning of 426.4. It's the amount in euros. It's the amount in euros. Any questions? And the next part, it's still about the ratio. It's really still about the ratio. And it's the so-called constant proportionality. And when we have multiple ratios, and sometimes all the ratios turn out to be the same. So that is the so-called constant of proportionality. And for example, this is the case. Isabel is working for a working part-time, and he kept tracking what she got paid for what she got paid for the different time period. And then this is a list of the amount she got paid. When she works for 7 hours, she got 87.50. And when she works for 4 hours, she got $50 exactly. 3 hours, 8 hours, these are the amounts she made. And then if you look at the ratio, okay, 87.5 over 87.5, this should be the denominator, 5 there. Okay, and then we get a 12.5. And then if we look at the ratio, 50 over 4, and which is the same amount. Similarly, hopefully you see the point, 37.5 over 3, 100 over 8, we got the same ratio, 12.5. So now we see, Isabel, it is working for a part-time job. The rate she is earning, it is $12.5 per hour. $12.5 per hour. You see, all the numbers have a specific meaning. Okay, all the math terms have a specific meaning. In this case, the so-called constant of proportionality. It is the amount Isabel is making for 1 single hour, the hourly rate she got paid. Okay, that is the actual meaning of the constant of proportionality. So I think this should be it for section 5.4, ratios and proportions. And just as a summary, make sure you understand how do we form a ratio correctly. I would say usually in math, we just simply write a ratio as a fraction, okay, as a fraction. And also for reviewing purpose, when you are solving a problem involving with ratios, and the cross multiplication rule might be helpful, like this example we did. And this is a more generalized fashion for cross multiplication. And otherwise, I think, you're going to tell me if you have any questions. Okay. And section 5.4, ratios and proportions. Thank you for watching.